We will now continue with two PhD talks again. And the first one that I want to ask on the stage is Olaf Adan, and he will talk about moving beyond the prompt.
Hi.
Yeah. Okay.
All right. Yeah, this is on. All right. Hi. Imagine some AI-enabled technology is over there. Now, there's three things I can ask you about it. What does it look like? What does it do? And how do we interact with it? Now, I'm personally fascinated by how we communicate our knowledge and understanding of things. And in my research, I explore new ways to use and interact with AI-enabled technologies, specifically in ways that go beyond the scope of our personal devices. So if we ask ourselves, what does AI look like, we often get something like this. Some humanoid robots, some digital brains, or some visuals with a chip that says AI. So what that does is, if we ask ourselves, what does it do and how do we interact with AI, it results in limiting ourselves to human-AI interactions that are defined by the way that we interact with each other as human beings. What that means is we ask something or we give a command in order to obtain a result. Now, of course, this is not just because of how we interpret AI, it's just how AI works, right? We give it some input, a bunch of machine learning tied together, compute things, and then we get to some output. In fact, this is actually just the interactive loop that underlines human-computer interaction. Now, that works perfectly fine for single-user devices, right? It's back and forth between human and computer. But what that means is that also most AI-enabled tools are accessed through personal devices. So devices that are designed to cater to individual activities, user needs, and preferences, and are not optimized for in-person, multi-user collaborative contexts. So yeah, this works. You can see like this interactive loop of input and output coming together. But then let's think about like a multi-user in-person context. So let's think about in-person meetings. Now, the power of in-person meeting is that it enables us to better communicate and reach common ground. So the last thing you want somebody to do during a meeting is go to ChatGPT and prompt an AI and to get a result. Because if anything, that's a meeting that could have been an email. And now let's reflect on in-person meetings, for example, just meetings in general. I mean, aren't they just great? They're really collaborative endeavors in which a lot of progress is made. And of course, this is because our personal devices support us so well in collaborating, because we get to take our personal notes, and then we send that to the secretary, and then this person has to interpret those notes and create meeting minutes, and then 2 weeks later you receive them, and they just make sense. Yeah, and then really they just like, I mean, it keeps you focused in like the moment and the task at hand. Sorry, I just got an email. Let me quickly reply. Now, as you can see, personal devices are nothing but a distraction when it comes to in-person communication. So this works, but this doesn't. And if so, how do we then integrate AI into collaborative settings? How do we avoid the distraction of personal devices and move beyond the prompt? Because what we're kind of looking for is something like this. But then, yeah, what does AI do here? And how do we interact with this? Now, in order to answer those questions, we have to reimagine how we imagine AI-enabled systems. So let's try that together then, shall we? So in the context of in-person meetings, and we put personal devices out of the equation, so I guess we need some sort of shared screen. So voila, share screen. Now I'm collaborating with you guys, but I mean, this obviously doesn't work, so maybe we need to position it in a place that works better so we can face each other. Say, a tabletop system. Then we can ask ourselves again, so what does AI do here? Well, maybe if we like talk, it listens to the conversation and then generates a bunch of post-its. And then how do we interact with it? Well, we can use it to create a mind map or like arrange it in a way that works for us to understand each other. Or maybe we can even pick it up and stick it to the wall. Now, I'm still working on the last part, but that's actually the system that I built. And I decided to name it Collegal. So in simple terms, Collegal is an interactive tabletop system that is AI-infused and leverages natural language processing to enable collaborative note-taking in a tangible manner. Now, as you can see here, this is what it looks like. I don't know if the lights can go down, maybe. So here you see people collaborating using Collegal. So basically how it supports collaboration in that it immediately gives them the content of their conversation. It reflects the content of the conversation. It extracts parts from this conversation and posts it onto the screen as post-it notes, which is now played at 8 times the speed. And all it's left to do for the users is just to take an item and put it in place. And then they can use this to organize their ideas and structure their thoughts. So that's already pretty neat. But this also enables us to kind of create outputs and documentations that go beyond just like one snapshot of meeting minutes. We can actually store the whole collaborative process. And what's also interesting is now it's just stripped to this very core idea of like a white background and post notes flying around. But what happens if the background is a map and we're trying to do infrastructure planning? What if it's a business canvas model and we want to create like a business idea? So there's a variety of use cases that we can kind of use this. Now you might ask, Olaf, what does this even remotely have to do with AI? That's an excellent question. See, the interesting part is that the outputs that you create in using Collegial is in fact a topic model. Also, it collects that underneath, but it's a map of words that can be vectorized and encoded to enable the integration of pre-trained generative transformers, also known as large language models. And as such, by coupling physical artifacts and natural language, Collegial offers a way that we can tangibly interact with AI and fits to kind of the language models that we use now to create things. So that's pretty cool, at least in my opinion. But that's only one way that we can use natural language processing and leverage it to enable new forms of AI interaction. So yeah, now we're coupling natural language processing to physical artifacts, and then we get to a tangible form of human AI interaction. But before we can explore new forms, we have to understand how natural language processing is actually leveraged. I'm just going to say NLP from now. How NLP is leveraged, and also what this means for interaction, or like for human AI interaction, and specifically the purpose of human AI interaction. So basically how natural language processing is leveraged is that we, rather than using explicit interactions to provide inputs and then generate an outcome, we use NLP to continuously provide inputs to the system implicitly, by which we continuously get outputs. So it's just a continuous stream of in and out. And what does this mean for interactions? Well, then we have our hands free, then we have our mind free. So the only thing we have to do now is see what is being generated. So we can employ AI to generate a variety of things here. It's just determined by how you sample basically the transcription and what kind of interactions you couple to what kind of components of the transcription you take. And what this does for the interactions, if you have like an AI maybe generating specific images or a whole range of images or just samples of code blocks, you use explicit interactions to curate and guide the AI-generated outcomes. So we implicitly provide input to create things, and we use explicit interactions to curate what is useful. And just like that, we move beyond the prompt. Thanks.
Wow, thank you very much.
Oh, wow.
It's a very interesting talk.
Thanks.
Very to the point, very clear, very interesting topic. Does anybody have a question about this? It's hard to see with the light. Yes, I see a hand there in the back.
It is difficult to see, yeah.
Yeah, it is difficult to see here.
Thank you. I really enjoy the concept you've developed. Why is it on a tabletop? Why is it not like a bit nerdy perhaps, but like Jarvis, who is listening in like in the Iron Man movies and then contributes to the conversation live without being asked to do that even?
Yeah, good point. The original idea and the concept in my mind was actually to just have holograms pop up. So I speak and I have a cloud of words alongside of me, and I walk about my day and I have it. But at some point you have to step back into something that is actually feasible and realizable, so you can then show the idea. So ideally I'd have that, not necessarily always with like the agent form in which you ask questions, although having a mix between both I think is like a great outcome. So yeah, might have been an inspiration, like unknowingly, but fair point. It's just to like, yeah, have something feasible.
Yeah, love the
Step one.
concept. Thanks.
Other questions? I thought I saw another hand before, but now I don't. No. Ah, that's somebody calling. Are there any other questions? Yes, one question here in front.
Yeah, you were going a bit quick in explaining your concept, and then you were talking about physical artifacts. Can you elaborate a bit more? What is the physical artifact in your concept?
I'll go back to the video then, if the button works. I don't think, yeah. Aha, yeah, okay, there we go. So here basically the blocks that are being placed on the table are then the physical artifacts. I have to click back again for it to
what
play.
do they do? What do you do by placing a block? What does it
So
mean?
yeah, thank you for asking that also. Maybe I didn't elaborate. So basically, when you put the object onto a post-it, it basically becomes the post-it. So you can see that the content that it's like on the post-it before is now rotating around the item to show that it's like tied together.
See that.
yeah, maybe a bit. Yeah, it's difficult to see, but that's basically the physical artifact. And now I built this using a depth sensor, so you can basically use any artifacts. Now I just used the simplest form, but you could also use your coffee cup or just like, yeah, maybe like a figure of a person to show like this is a person with tasks that you then assign by moving it around and collecting post-its.
Okay, thank you.
Great question, thanks.
Okay. Any further questions? Yes, I see another question there just behind you.
When are we gonna see the startup, Colleagual?
Startup. Yeah, I'm sorry, I'm an academic by heart. I just build stuff and then I leave it to you guys to put it in place. I just want to explore and build cool things, yeah.
Okay, then maybe someone here wants to try.
You can hire me as a consultant though. That's where I get the bag.
Yeah, this is also a networking event, so take the opportunity. Okay, are there any further questions? Well, thank you very much for this very interesting presentation.
All right.
Okay, can I have the clicker? Yeah, thank you. And now I would like to welcome Pei-Ying Lin on the stage because he will be discussing our respectable creative non-human partner in Textile. Here you are.
Yes,
An applause,
thank you.
please.
Yeah, so before I start, I would like to ask the audience who knows how to knit. Can you raise your hand?
Oh,
Okay.
wow.
And then the second question is, how many of you recognize a piece of knitted textile on your body? Like, can you raise your hand? So some of you might not be aware, like almost all the textile you are wearing right now on your body that are stretchable are knitted. So what is knitting? Knitting is basically using a string of yarn and you form loops, and these loops interlock each other. So my study is actually how human and AI can collaborate on textile making, and particularly on knitting. So since there are not so many people who knows how to knit, and probably even less people who have the experience of knitting with machines, I want to explain what happens. So basically with knitting, you have a different direction of the yarn loop, and by having different direction, you can form different shapes. So as you can see, I'm wearing knitting all over me. With my skirt, it has pleat, but it's only one kind of material and one kind of knit, but in different direction. That also happens during the process of knitting, but sometimes with different yarn, like you can have the same kind of yarn, but different color, it can also perform differently. And sometimes your knitting machine, and like sometimes your 3D printer, can go angry and doesn't want to knit, and everything just stuck together. That happens all the time. So it's always like for a craftsman or for a designer, textile designer, in the process of making, you really have to listen to the material and really see why is it happening. Sometimes some error happens, and as a textile designer's language, they call it surprises. So they try to implement those surprises and create new things out of it, new textures, new patterns, or things like that. So for a designer, you're already trying to implement that. So what if we bring AI into this process? And you might already see a lot of examples of people using Midjourney and Stable Diffusion, where they generate interesting images, where these images have interesting context. So I'm also looking for a similar thing, where how the AI can integrate in this process of textile making, and instead of trying to optimize something or trying to find existing patterns, it suggests new concepts, new combinations. And because of all the problems I've mentioned before, that it's very sophisticated, so I see the whole system as assemblage. So this assemblage collaborate together, and they create textile. And the textile tells the story of the assemblage. And because of these sophisticated codependent element, I see the whole system as a complex system. Complex system means that you cannot deduct it, so you cannot make it simpler, and you have to study it at that level of sophistication. What's interesting about it is that sometimes new characteristics emerge from there. So I'm looking at the emergence of new characters. In order to able to study that, together with research in the industrial design department, we have hacked a domestic knitting machine that was built in 1970s that take a punch card. So punch card is a card that has holes, and it contains the information of a pattern. So we hacked that, and we have a hardware that can connect to the knitting machine, but also to the computer. And then I built an interface on top of that where you can select the patterns or each single needle on the interface that's built. So that allows you to have a much shorter feedback loop between knitting. So you can immediately create one line of pattern and then knit it immediately. So you can see how the material perform, and then you can also see how the machine perform. And then from there, the AI system is connected to the system. And because it's a complex system, so there are flow of informations. So if you see it as an ecosystem, then you can imagine that you have the entity of human, you have the entity of textile, you have, material, and then you have the entity of the machine. And the AI coming into this system, it has to speak the language of these parties, and it's nonverbal. So from there, I also study what kind of language do the knitters use, which including the materiality of the yarns, the type of yarns, the stretchiness, the drape, and all these embodied information. So it also challenges what is the necessary information within the data that we need for these kind of generative AI, because the current design field are widely using Stable Diffusion or Midjourney for generating new patterns. But the problem is it's very visual-based and doesn't have the embodied information. So it often creates images that's not actionable for textile designers. So I'm tackling into that and trying to build up a new database, and which, along with that, integrating the AI system to it. This is one of the early exploration that I'm using the evolutionary algorithm to generate what hybrid existing patterns and to see what kind of new patterns come out of it, and also trying to knit it, which, as you can see, some of the errors happen on the top one, that it becomes unknittable. But somewhere in between the unknittable and the knittable, there are some interesting patterns emerge from there, and where these patterns are hopefully in the system that I'm building in process will be implemented further for the designers, so we can really co-create with the AI. So this is an AI-generated image of a Midjourney's interpretation of how human and textile and AI and machine can have a small ecosystem. So my goal is trying to create a complex system that's resilient and vibrant, that can generate as much more idea as possible, that allows the designers to explore the creative space much more efficient, and perhaps also much more personalized, because you will be creating the database while you are also making your design choices. And we all know that designers have a very personal approach in their practices, and that makes a designer distinctive. So this is my research right now, how to enhance it, how we can collaborate with AI, and really help human and AI grow together. So yeah, here is my information. If you have any questions, you're welcome to contact me, chat with me, or ask right now. Yes, thank you.
Thank you very much for this interesting lesson. I don't know how to knit, but if I see this, it sounds so interesting, together with AI, to start knitting. Thank you very much. Are there any questions that you would like to ask? There, sorry.
Yes.
Yeah, very interesting. I was just thinking about job shops problems in industry, where you have a lot of machines. It's complex, long routings, and it's all about on-time delivery, having the resources well used. I was just thinking, perhaps that's also a concept of knitting, of trying new patterns and see what works and what does not work. So is there perhaps an application of your thinking, of your research, to optimize production, routing problems?
Well, not necessary, but in a way, yes, but not directly. So I took some courses that's really related with the industry, where they would do, like it's a knitwear developing studio, and they take cases from famous designers, and then they do the design for them and then put it into production. What happens in this process is very often the designers don't know how to knit, or they don't prototype. They just send them an image and say, can you try to do that for us? And a lot of costs come out from there, because if you don't know the technique, you haven't experimented, then your imagination with what's achievable will have a bit of distance, and very often you need to use a lot of things to improvise it. From there, once it goes into production, then there's more waste. So my goal is actually how you can explore and ideate much faster, but also more producible in a way. Because then you're really ideation on the machine, then it makes this distance between the technique, actual technique, and the more like the designery ideation part much more closer. And also by bringing it together, then you're not trapped in this very image-oriented way of thinking, and that allows you to explore more structural, material possibilities. Yeah.
Any other questions? Well, this actually reminded me of this experiment that there was with AI composing music. And when the musicians really read the musical notes, they found out that it couldn't be physically played by humans. And this is what this reminds me of. And at the same time, I'm also thinking then, you're probably familiar with DeepMind, Alpha DeepMind playing Go. And because of what happened there, of what the machine learning learned there, we as humans started playing Go in a different way. Does this also mean that we could start developing new knitting techniques because of what AI is going to teach us?
Possibly, because even with my early experiment of trying to mutate the patterns, I already see some patterns that are so sophisticated that I won't think about it. And I tried it with some other textile designers, and they also have that expression. So the human perspective is indeed different from the machine perspective. Yeah. So potentially, yeah, we might be changed, and you also see the aesthetic change because of like stable diffusion and mid-journey influencing the graphics designers.
Absolutely, we have to learn to think out of the box to start. Okay, thank you very much.
Thank you.
Thank you.